Hello everyone, good morning, good evening, good afternoon. I don't know if anyone's watching. I think no one's watching because I've just pressed the live button. So if you are watching on the replay, thank you, appreciate it, appreciate your time. Please subscribe or like or leave a comment, anything, let me know you're there. I want to hear from you. Now, what are we doing today? Yesterday, we kind of left off in the middle of a review. We were doing reviews for a whole bunch of code that I've had open up for a couple of weeks, and I need to commit some of it because we need to move on. And as we were going through various things, I discovered some bugs, some things that are not quite right, based on some things I was testing, and I've forgot that I was testing them because I moved on to something else. So we need to go and look at that today. Need to go and investigate what's going on. It'll make more sense when I kind of dive into it. But I've already been doing some work this morning, kind of cleaning up some of the other reviews. There was a lot to go through. I want to get back to coding as soon as we can, but we've got to make sure that our code that's going in is crisp and clean, and is something that, more importantly, when we come back and read it in 6 months, is it going to make sense? We're going to look at it and go, why do we do that? And that's one of the key things to maintainability, to good system design, good architecture, good hygiene, good code hygiene, is thinking of your future self or the person that comes in behind you. Are they going to look at your code and go, yeah, this is clean, it was well designed, it's good abstractions, and I can work with it? Or are they going to look at your code and go, what on earth were you thinking? Were you drunk? Were you smoking something? Herbal or non-herbal? Anyway, it's that realization that, oh my God, I've created a horrible mess. I've created such a disturbing amount of chaos that I just got to scrap it and start again. I can't understand what I've done here. I've been there a few times where I've just created spaghetti, been in the moment, this is before vibe coding. This is, just wiring things together. And you don't know what you're doing half the time because you're experimenting, and then you forget that, like I've done today, like you're experimenting with various things, you walked away, and you come back and you can't remember where you left it, unless you have left yourself a very clear set of breadcrumbs. It's really hard, and to kind of get yourself back in the mode and get your brain re-engaged, remember where you were. So that's what we're doing today. We're going to be going through some of this code again. It's not the interesting stuff is what I want to look at. This is new stuff. This is things that are really important in software design as well. These are things like API rate limiting. We started to look at some of that code today and yesterday. We never got into it. Had to switch to other things, and there's also got some file compression. In fact, I'll walk you through some of this stuff of why I'm doing it, things that need to exist, and some of memory management things I'm looking at. Again, this is all based in Go and TypeScript. If you're interested in Go and TypeScript, that is what I'm working with today. In fact, that's what I'm working with 99% of the time, if just in case you didn't know. Yesterday I had some problems with my audio because I didn't set things up properly. I've spent more time getting things configured properly today, so we shouldn't have those issues. Thank you for sticking with me as I learn the ropes and all of this and get this muscle memory and get my, find my rhythm. I haven't found my rhythm yet with how I want to organize things and organize the stream. So these are all my early days trying to figure things out. We'll get better, I promise, as we go on. And I'm gonna need more coffee. Got a bit of a dry mouth. I wonder why. Anyway, where are we? We are looking at some rate limiting code and some compression code. I want to explain why. I'm going to put my little me on. Little me down here. I'll stay down here for the rest of the day. You don't need to see my face up big and centers. The code we're looking at. Got some. Hang on. We're looking at WebStorm at the moment. So this is not what we're looking at today. Let's switch over to some of this Go. And it's all in green because today I'm using JetBrains integrated diffing tool. I was using Kaleidoscope yesterday, which is my preferred tool, but it's a bit quirky to work with on stream at the moment. I haven't figured out a good workflow for it yet, so dropped back to JetBrains. I love JetBrains. They're brilliant. If you want a real tool, if you want real tools that work for professionals, JetBrains. I pay for a personal license, and I have one at work as well, but I would pay for it. They're that good. So, what are we doing? And I'll stop rambling. I'll get to the point. In fact, what I'm going to do is I'm going to come over to Chrome here, and I'm going to show you. This is the architecture of the Doctor. What do I mean by the Doctor? Let me bring up a new tab here. We'll go to pbeef. And then we'll come over to the Doctor. This is the OpenAPI Doctor. And this is a product that I've been building. This is a platform. This is running live. And these are the components of the platform. There is a single service. It's very small. Runs on next to nothing. We've got Postgres. It's a database. And just maybe I can zoom in there just so you can see that a bit better. And then we have, I've got an instance of memcached, which I call my RAM drive. I have a two-tier system in the platform where if you're running locally and you don't have memcached, it uses the same interface, exactly the same interface, so you know the rest of the application has no idea. But it uses an in-memory system called, it's part of the ranch actually, it's stores in the ranch, it's a mechanism that, and I'm not going to go into that because that's a whole other deep dive. If you're interested, we can do it on a stream if you let me know. Anyway, this is the basic architecture of this application. Super simple. This is my production. I've got another staging environment which is I call Playground, which is absolutely identical. And I update that whenever I'm testing big new changes, and I go through and wipe the database and blah 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 blah. Anyway. Why is this interesting? So let's take a look at the observability tab. I'm going to just show you a few things here. This is how much money it costs to run on a month on average. And that never hits that because it just never does. We're running at about $10. And that's, we're using anywhere between 200 meg and 3 gig of memory. And these are peaks that I'm going to fix. I'll get out of the way there for a second. There. I'm going to fix that one. And then, where's this one? There. That one up there. These are anomalies. They are where I've made a mistake in some of the code. I just haven't deployed the fixes yet. I found the fixes. Just a case of loading too many bytes in, not using correct streaming. So that will all be resolved where those massive peaks exist. But you can see that the system recovers quite nicely. And you can see this is actually a very obvious business tool. These are weeks. So this is over the last 30 days. And you can see where the weekends are. Next to no use, and then bang, right in the middle of the week seems to kind of peak and then tails off towards Friday. So where we are, Tuesday is a here day. We see those second peak. You can even see the lulls in the days. It's very obvious. Business. People use this for business, which is great. That's what it's for. And who does this for fun? No one uses OpenAPI for fun. No one does it for fun. Well, except for me. Well, I make tools for it, but I don't love using it. I can't wait to build another OpenAPI spec. No. No, I love building the tools that manipulate and utilize the standard. It's the tools, it's the code that I love, and the problem. Anyway, you can see I've got this pretty repeating pattern where I've got these spikes of memory use. and that's actually where I've got a compression problem, and I'll come into that as well on the stream. But you see these massive spikes of memories, but you can see generally it recovers very well. It recovers all that memory back, and it goes back to a reasonable, we're talking, it averages around about 400-500 meg of memory, and that's supporting a lot of traffic anonymously, and a good number of users as well. And we've got a spike over here. Well, not really a spike, but we've got a growth, an uncomfortable growth that isn't going down. We're using about 970. It's about 960 megabytes for the last week or so. In fact, we can bring that into the last 7 days and take a look at that. You can see for the last 7 days it's gone over 500. Oh, there's people running in real time. Okay, it's just an error just popped up. That's not an interesting error, that's an old error. Don't worry about that. Not actually an error, it's just an error. I've made it an error, I don't know why. Anyway, so you can see the memory's kind of creeping up. So there's a couple of things that I've built, I'm going to be kind of reviewing today. One is better use of this, like these massive 40 megabyte spikes. That's JSON files. That's massive amounts of JSON files, and it's because of an earlier bug that I fixed in the Doctor, but it's also because storing very large files, and that comes over to this point in this disk usage. Let's pull out to the last 30 days, and you can see that 30 days ago we're at 22 gig, and now we're at 25 gig, and so we're looking at good 3 gig a month of growth. That's after I've done a lot of optimization already, but it's still even optimized, and this isn't optimized, by the way. It would get even less, but growing at that rate, and this is permanent storage stuff, by the way. This is not ephemeral data. There is ephemeral data for anonymous users, but that's all wiped and deleted every day. This is like genuine steady growth from users, building YAML and JSON, and it's starting to grow, and it's 25 gig. Yeah, who cares? It's absolutely nothing, but it kind of matters to me in terms of scale, because you extrapolate this number and we're at ridiculous values. If you're using this as as a tool internally, which it will be available to do that, this storage could get out of hand, particularly if you're running pipelines and you're storing every revision, and there's thousands of specs across. It could get. Luckily, it's pretty controlled. The anonymous stuff is all wiped out. That was growing at like 10 gig a week, but that it's all basically wiped out now. So it's kind of cleaned out. Hey mate, sorry, I just seen that chat. Hey mate, I love your stream and enjoy being part of your fan community. Would you mind adding me up in Discord? My username is. Oh, okay, yeah, sure. Sorry, I didn't know. I haven't got my Discord open. Oh my goodness. I've got the Discord open. Let me even open that up. Oh my god. How did I mess that up? Oh, now I'm going to install 18 updates, because I haven't opened it up since yesterday. I will add you. Yes, I've got it open now. I've got your username up here. Thank you. I'll add you. You can come join my actual Discord where the community is, or my community is, and I'll add you up there. I'm going to continue for this for the moment because there's quite a lot to go through, if you don't mind. But I've got a note here. Thank you, appreciate it. Thank you very much for your compliments. So basically, there's growing storage. We've got to take care of this, and they've got these peaks and troughs, which is something else that I'm actually worried about. Which isn't this? It's AI. To be honest, you can see these logs are ticking over in real time. There's connections, and there you go. So this is like people using the system in real time. I'll come back to. Let's change it from 30 days to like the last hour. Let's take a look at kind of real granular use as it's going through. And you can see, look, there's little peaks and troughs of memory use. Let me just bring that up so you can see a bit better. And then I've got my 3 services, my memcached, Postgres, and my application that's running there. Anyway, I need to sort this disk problem out. So the first thing I need is something I've already implemented is it's a design that I've been pretty fond of. It's pretty traditional design, but all of my file access is done through interfaces, and I've got managers. So I've got the concept of managers, which are low-level concepts, services which use managers for low-level access to databases or storage or whatever they might be. And then I've got my kind of controllers, which are listening to and from API endpoints, and they then orchestrate services, and they call services to do various things, and the services then have granular access down to the managers. That's like a design pattern that I've implemented over the years. Is pretty standard. It's called various different things. I've stuck different pieces together, but it works very well for me. It helps me organize, what level of granularity am I? Am I at state management, or am I orchestration, or am I controlling of orchestration, or am I simply responding at the very top level in API controllers? Let's be kind of be clear in where the level of complexity of the logic is. So anyway, I've got this, as I said, I've got this manager system that reads and writes to and from disk, and I've abstracted that to the point where it also does cloud reading and writing. So the idea is that you can spin up any instance, and it'll have a local instance of a disk attached, and it's going to go looking locally for that file, and it's in a particular folder and a particular data structure. So it knows where to look, and it's all kind of organized pretty nicely. But if it doesn't exist because it's a brand new instance, or it's just been spun up, sorry, I was just distracted by Discord there for a second. I apologize. But if you spin up this new service and you need data, where'd you get it from? So everything comes from like an S3 bucket. Actually, I'm using Google Drive, or whatever it is, Google Cloud Storage. Sorry, not Google Drive, Google Cloud Storage. The idea is you can swap out the interface, right? You can put any kind of blob or bucket storage behind it, and it sits there in the cloud. So every time you save locally, it's also doing a shadow copy to the cloud and backing it up permanently. So it's all private and secure, but it is making sure that if that instance goes or that local volume dies, nothing is lost. It's all good, all good. So that's pretty standard. So you've got local cache, super fast. You've got kind of a when needed backup from the cloud as you kind of boot. But if we're doing like 25 gig here, it still can be massive. That can be absolutely massive, and will grow and grow and grow and grow and grow. And then you're paying and paying and paying and paying. So how do you reduce that? Well, one of the wonderful things, because all the files I'm dealing with are text files. They're all text files. They're JSON files. They're YAML files. They're markup files, essentially. All of it, everything. Maybe some graphics eventually, but genuinely it's just the majority is text files. Text compresses extraordinarily well through compression. Well, how else would it compress? Anyway, it compresses extremely well, really well. So you've used compression when pretty much every time you use any kind of modern web server or website. If you take a look at the headers, you'll see like a gzip header in there that says that this has been compressed. It's been compressed on the server. So what the browser actually gets is a compressed stream versus the raw text, and it does decompression on the fly. Just because it's fast and it's easy. So what you're doing is you're actually sending compressed data over the wire, and you can see that massive reduction in traffic. At least a minimum of 30 or 40%, minimum, absolute minimum, often a lot more. So that's what I do. when I'm saving files. I'm saving them, I compress them transparently and save them to the cloud. When I read from the cloud, I decompress them transparently and read them in. So the application has no idea that stuff is being compressed and it's being read and compressed. It's the same mechanism we use in browsers. It's transparent and it works flawlessly. Now, I use that for cloud storage, but I don't use that mechanism for local storage. I store the files raw, and hence the problem. This is where this issue is growing and growing and growing. I want that disk usage to be like 2 gig, 3 gig. And not 25 gig at this point. It shouldn't be that high. So how do we do that? Well, we got to add transparent compression, and that's what we're going to be looking at right now. Go code. All right. So this is a few different things. There's API rate limiting code in here, and actually no, that's in another project. We'll look at that maybe in a little bit. But this is the compression code that I was talking about, and I was just starting to look at this a little earlier before I started the stream. The reason why it's all green is because it's a new file. That this is how JetBrains shows me that it's a new file. I mean, it's green, but anyway. And the way that I've actually had this built by Claude yesterday, but I gave it the specification to use what I've already done for the on-the-fly decompression. And what it's done is it's built me. What are we looking at? This is our compression.go. So here it is. Here's our unversion file. These are all our new files. Compression.go. Why is it zoomed out? So let's go from the top. There's these 2 magic bits, which is really, really important. This is all Go, by the way, if you're interested, or if it's not obvious. Anyway, here we're using these magic bits. This allows me to look at the file and determine, is it compressed or is it not compressed. Sorry about that. Needed to cough. The first bits, like it's essentially you read the first byte and say, is this a compressed file? If it contains one of these, we got 1 and 2. These are, it's keys. Like, this is the most efficient way to determine that this is a compressed file, or a gzip compressed file, is by reading these bits. And what I do is also using a pool. So when you're reading and writing lots and lots of files, you're not kind of grabbing huge amounts of memory all the time. You're using a pool, a memory pool, a buffer pool, and well, it comes from a pool, but it's a buffer that comes from a pool. So it's like a reusable data structure that comes from a pool that reuses memory, if that makes sense. I could probably go into a bit more deeper if you want to, but or if you leave a comment or whatever. But anyway, so I've got a compression buffer pool, which is like this reusable piece of memory, and then a writer, which is again comes from a pool, which allows me to recycle that, so we're not kind of grabbing all these new handlers over and over and over again. Excuse me. Bit of a frog in my throat today. So this is what these variables are. Those are existing pools. So I was talking about this first thing is it gzipped? So what we're going to do is when I'm reading and writing, I'm going to be calling this, and it's basically like a pass through. If it's gzipped, do run this. If it's not, then bypass the system because we don't need it. All right. And really everything is going to be gzipped at some point, but you've got to remember I've got an existing massive files. There's, I don't know, hundreds of thousands of them. I could go into the stats, but I'm not going to. We'll do that later. But there's loads of them that already exist, and they're not compressed. So I need to have this fall through that it can eventually be removed. But for right now, I'm going to need to keep this in. And then what it's doing is it's actually going through and reading. What it does, it grabs a file handler here, and it obviously exit out. If it's, let me zoom in a bit more. It grabs a file handler, and it will exit out if it's no good, where I can't get a file handler, then what it does is it makes a 2-byte array, it's a byte slice that is with a length of 2, right? So we're just going to read the first 2 bits, or 2 bytes, sorry. All over the place today. And then we read in the header. We read in that much, which is the header, which I was talking about, those magic bytes. And then we're going to return it and say, is it this one or is it this one? I'm not sure why there's 2, but there are 2. I think it's just maybe different versions. Not sure. Not sure actually why there are 2 different. I can go into that. Should maybe go into that. Maybe not, but let's continue. Anyway, so it reads, and these I guess we could fix this as well. It's not very good, is it? That comment's not very good. That's not very good. Anyway, if it's not, when we're writing, if it's more than 256 bytes, then we compress it. Other than that, there's no point. That's what this number here is for. The min compression size is like if there's something is coming in that's tiny, which isn't gonna, it's probably gonna be an error, to be honest, or an empty. I don't know. There's something gone wrong because there's not much we can do with that in the system. But where are we? Gone past it. There it is. No, we haven't gone past it. So if it's less than that compression size, then just exit out early. Then go ahead and we get a buffer array. Or buffer slice, sorry. Yeah, that's what it's called in Go. That's the terminology we're using here. And then this puts it back, but the defer runs after compressed bytes is finished. So once it's done the job, it's going to go and put that back in that buffer slice back in there. Well, it's not a buffer slice. It's a buffer is a data structure that contains an internal mechanism for maintaining a slice internally that reuses the same memory over and over, and that's what this reset button or is it a button? Do I call it a button? Yeah, it is a reset button. It's a reset button on the buffer. I like to give anthropomorphic. No, what's it called? Isomorphic? No, skeuomorphic. Skeuomorphic. That's what I'm looking for. Skeuomorphic. Got out to go the whole gambit there to find the right one. Yeah, skeuomorphic things against methods. Okay, so we're basically just writing the compressed file, and if the compressed file is smaller than the data, then it's added value, then we use it. Otherwise, just give up, because it's what we're doing is pointless. And it returns a copy of the byte slice. That's it. This is, let me just do it in reverse. Same thing in reverse. Read it in, gzip, read in the bytes, and then we use this pool to get and read those bytes into buffer. We copy them out, and then we return them. And this defer, where is it? This puts the buffer back in to the pool and recycles it all the memory. And then we have the kind of write compressed file, which is, again, it's like this is a defensive programming. Defensive programming. I don't like these comments here. I don't like them. This is not Godoc, by the way. None of this stuff is Godoc. This is Claude not doing smart things. Reads like somebody with broken English. All right. Okay. So I'm okay with it, but I want Claude to fix some things. So let's Let's do this. Let's do this. Whoops. Claude. Alright, here we are in Claude. And what folder we're in? No, it's called Bunkhouse GitHub app. There we go. We're working on some new code. In particular, we're working compression code at the moment for compressing, reading and writing gzip files. Everything looks fine in terms of the code, but the comments that you've added for the public methods are not proper Godoc. Can you fix this, please? Godoc. Let me just make sure that that reads correctly. All right, it's taking a look at it. It's going to fix it. Whilst we're moving on, let's come back to. Actually, I'm just going to let it go. I'll come back to if it needs any questions. But in the meantime, let's get on to compression migration. So another thing that I've needed, right? I'm going to need is once this mechanism is in place, I want to be able to then move everything over. And you know, there's a couple of ways to do this. I can build a script that would do it, and essentially what it's going to do is compress all the files everywhere and make sure that everything is looking good, and update any of the database needs to be updated. Oh, hang on. Claude is just telling me that all the docs have been fixed. And let's go and look at that. Yeah, there we go. There you go. So this is the correct way this is the correct way to implement Godoc. So I'm going to just put my phone on do not disturb because it is driving me nuts. It is buzzing in my pocket. There's just a million things going on. It's like ugh. Off. I'm gonna focus on the code. So yeah, we fixed all of the. This is good to go. That's good to go. I'm happy with you. So let's go to the migration. The migration is actually it's a job that's going to run, and is going to go through the many files that exist throughout the live application that are going to need to be migrated. They're going to need to be compressed, so I can eventually get rid of that. Excuse me, I've got a bit of a throat problem today. Sorry, it just keeps catching there for some reason. Not sure why. Hello, WebMDPL. Good to see you. So we're talking through compression today. Compression, it's transparent compression that happens on the file system. You can go back and look at the stream if you want more context on it. But we're looking at a job now that's going to run in the background and essentially migrate all the existing code that's already been created through the system and people already have logged in their accounts. There's lots of it, like, because everything in the system is generated once at runtime, so it's like a snapshot in history. It'll never change, it'll never be re-rendered. That rendering is permanent, so whatever the system looked like, it will stay like that, and that's by design. So it doesn't, continuously run everything on demand and just chew up an ungodly amount of CPU and memory. But it means we've got to store those files, and this migration tool is going to read all the files, and so this number of workers here is based on the number of CPUs, i.e. number of cores that you have. So num CPU is essentially, if you've got, for example, I have an Apple M4 Max, and that has 16 cores, which is, it's top end for consumer-based CPUs at the moment. It will change next generation to, 18, 20, because you can get like the Ryzen Threadripper, which is like 24 cores. It's like nuts. I don't know why you need that. I don't know why anyone at home needs that unless you're doing crazy experiments. But anyway, I've got a robust CPU. It's got 16 cores in it, which, a decade ago was insane. Now is normal. And this will determine how many workers to run. We don't want to go too hard because you can actually overwhelm a disk. You only speak Ryzen. Yeah, I've got a Ryzen CPU downstairs in my gaming machine. I built a PC. I like Windows. Let me rephrase that. Windows. I use Windows. I don't like Windows. I've never really liked Windows, but I do use it. Has its value, has its place. Just as a daily driver, nah. I have tried for many years using it as a daily driver, but I don't know. Anyway, I'm not going to get into the Windows. Talking about code. So what this job is going to do is actually migrate everything in the background. Linux is, sorry, the comment is Linux is terrible. Sorry, Linux is good, Windows is terrible. Linux is great as a server. I tried running Linux as a desktop for 5 years, and I hated it every day, and I felt really smart and really clever, and I really got into the mechanics of everything, tuned everything, drivers, the lot, and it brought me no joy. It brought me frustration, irritation, annoyance, and by the looks of things, nothing has changed. There's Omarchy, which is like Arch Linux, a few other things, and then there's trying to change that, but it's still the same hacker bodge job that has always existed. It kind of works. It's like Android. Get you 80% of the way there, and then that last 20% you're like, God, this is so frustrating. I hate it. And what you can't fix in this, the comment is, what you can't fix in Linux, Cursor will do for you. It has some quirks and has moved forward. Yeah. Quirks. There's those quirks that get in the way of doing the job. It's those quirks that pop up when you're trying to get something done, when you're trying to get real work done, and you can't get all the way there because of some incompatibility or a slight limitation in the driver or slight weirdness that means, I'll just drop over to my Mac. I'll just build Windows. It will work in Windows. This is like, it gets you there. It's a desktop. It's not it. It just isn't it. But as a platform or as a server or as any kind of workstation or a workstation headless machine, it is beautiful, perfect. That's what it does. The only platform for me. Anyway, back to the code. Anyway, this is basically going to migrate all this stuff in the background. It will run once. It's something that needs to be one and done. Once everything's compressed, it's compressed. Doesn't need to happen again. But I wanted to make sure that there was a reasonable amount of code in here that's going to take care of this. I've run it locally. It works fine. It's like completely invisible. And then there's some tests in here as well for testing those bytes, those magic bytes, plain text and things like that. So a bunch of tests to test the compression is working. It's all passing. That's the difference between EU and the USA. I don't get Apple things, but that's, yeah. Very expensive. I mean, Apple is expensive anyway. They're ridiculously expensive. But I tell you, man, it's stuff it just works. I've rarely had Apple products fail on me. I've been using Apple products now since 1998, almost exclusively for development. Almost. There's periods where I've used Windows because I had to. I didn't have a Mac and I didn't have enough money to buy a Mac. But most of the time, it was something from work. But now I can afford, my own Macs. Don't have to worry about that anymore. And I always kind of max out. I always hit the max out when, usually every 2 years now, I'll go and get myself an upgrade. And I max it all out. And I'm never disappointed. Like this machine that I'm using right now, it's a monster. It's an absolute monster. It's 128 gig of RAM, 8 terabytes of disk storage, M4 Max, Pro Max, M4 Max, sorry, not Pro Max. That's a phone. M4 Max. It's a monster in terms of it can do more than I can throw it. I haven't been able to barely spin the fans up, a few times. All right, so this is just compression stuff. So I'm happy with the compression. I'm happy with the migration. These are the test files it's created. I don't know what those are for. We can probably get rid of them. And then these are modified files. So in so what we're looking at here. This is the root. This is the root file of the platform. It's called the bunkhouse, and this is what starts everything off on the Doctor. This is where I configure. For example, I'm looking at over here. You're looking at. Let me zoom in so you can see this a bit better. Get rid of this for the time being. So stuff here, this is configuring the queues and the topics. This is using the background. You probably won't have seen it unless you're doing some deep analysis into how the tool operates, but this is the entire PubSub network. This is where I'm configuring things like free credit and the system. There's lifetime of the cookies, all kind of stuff in there. And if you're interested, this is all the different services that I have. Sorry, not services. This here is models. So I auto migrate my schemas in my database every time I boot. So because I use ORM for everything, and you can say what you like about ORM. That stands for Object Relational Mapping, which means that I don't have to worry about maintaining my database schema. I maintain my schema through code. And my code is the source of truth, and the schema is then replicated out and updated. And so I've got to be very careful about design, because once I write it, it's permanent. So changes are expensive. Altering the table is expensive. But I define all the objects that I store in the platform as models, and then I use ORM to read and write from them. The majority of the time, I do a lot of kind of raw queries as well and construct bits and pieces. But here's some stuff here. Like these are like creating index. This is the kind of some stuff that I need to remove, but I leave this here right at the root because I need to delete it. So I'm always looking at this and going, do I need this ugly ass crap in this? What the fuck? I need to remove this. So I keep it here. There's migration stuff in here when I've been changing things and I've been modifying things, and because it is ORM driven, I need to make sure that I then build custom migration scripts for some of these things that I can't use. I need more than just like a modification. Like I need to alter the tables in specific ways. This is the one that I'm working on now. This is actually a fix for something else. This is another thing. So I actually created, when I was creating an event mapping and users, when I did this probably about 6 months ago, I wired in some foreign keys incorrectly. And that code is live, which means the table's slightly incorrect. There's a back mapping for a foreign key which shouldn't be there, doesn't need to be there, but unfortunately it's conflicted with a column name that I need to use. So this here is a migration script for that. That's going to run SQL and update foreign keys and rename things that need to be done when it boots. It's only done once. So this code is only valuable once, and that's what these checks are. It uses information, so it actually uses from Postgres the information schema, looks at the columns to determine whether or not the change has been made, and will then run that query if it hasn't been made, and otherwise it just ignores it. And down here, so that's the only thing that's going on in there, mostly. And then down here is all my service configuration, like my IP blocking manager, which we talked about yesterday, storage, my rodeo service, that's my admin service. I've got IP blocking, and we've got down here all kinds of other stuff. Gatehouse, which is auth, my registration services, workspace management, wallets for credits, all kinds of interesting and fun things. But the thing I wanted to look at is this down here. It's the compression migrator, so I can turn that off once this has been deployed in prod once. I can then remove this block of code. So what I don't need to worry about is one of the designs I like to build in as well, is if I need to make changes to the system, I like to build that code into the system. So I've got a record of what I did. It's not some script that gets deleted or cleaned up or forgotten about. It's part of the system that I can then keep there and understand why it was run or why it was done, and then eventually, as it becomes irrelevant, delete it out of the system and delete that code. Okay, this is fine. There's not many changes in here except for, oh yeah, this is the other thing I wanted to look at. So the rate limiting code that we looked at yesterday on the yesterday's stream, this is where it's configured and enabled in. So I've disabled it for right now because we don't need the rate limiter. There's just simply not enough traffic happening on the platform that is warranting it, but I am concerned about, oh look, my wife has just bought me some breakfast. Isn't that kind of a... Thank you, honey. She's ignoring me. Thank you, honey. I'll have a bite of that in a minute. I'll have a quick bite of that in a minute. It's got fresh coffee for me as well. But I've commented this out because we don't need it yet. I'm preparing for the future on rate limiting, and I want to make sure that when I need it, it's there, particularly because I want to give priority to customers that are going to be paying for stuff. No one's paying for it right now. It's all free. All free. So you get what you pay for. But in the future, there will be that, particularly for people using the APIs, because it's all, it's one big giant API. That's what this product is. It's an API with a pretty face, so you can see how you can wire up the APIs, but really most people are going to want to do it themselves. That's my bet anyway. So it was commented out, which is fine for now. I don't need it to start up. I need the code to exist. I need it pre-wired, but I don't need it running yet, because it runs through... It runs as through the middleware design, so everything we're running through middleware. It uses the same type of Express.js. I'm not going to go into the middleware design. We can deep dive on middleware and middleware design a little later. If anyone's interested, again, leave me a note and I can put it on the schedule. For one day, we can talk about middleware design in different languages and what it means for different techniques. But anyway, I've got my own middleware built. It's pretty easy to build that in Go just without using any frameworks. So it's just commented out for now, which I'm good with. So let's Let's bring up where is it? Here it is. So we've got these. These are good, the unversion ones. I'm happy with the bunkhouse changes. This is the rate limiter that I was talking about yesterday. This is where we define the settings. Like we've actually implemented the rate limiter logic is in Ranch, which is in effectively the platform, and the bunkhouse sits on top of Ranch. It uses Ranch to create a platform. Ranch by itself is useless. You need an application to use it to create a platform. And this is configuring the rate limiter. So I'm sorry it's green again. This is how JetBrains do their thing, and I know I can configure it, but I don't want to configure it. It's fine the way it is. It's fine. We all like green. Green's great. So it's creating a new rate limit configuration, and I've got tiers in here. There's 3 tiers authenticated, which is part of the experience. You've got a logged out experience, you've got a logged in experience, and then you've got a premium experience. And you'll get different limits on requests, API limitation, rate limiting for different tiers essentially. And what I did was I wanted the ability to hook in custom logic for extracting keys like sessions, or pulling stuff out of the request like a cookie or a header. Like I want logic to be custom. So I don't want that hardwired into the tool. I want everyone to be able to bring their own logic for that. You know, do what you need to get out of it. And then you do once you've got that out, that key or that value, then you can then use that to resolve something. You can use that for a further logic. So this is what this tier resolver is for. So this is gonna, once I've pulled out the session ID, so I pull out like a cookie, I'll extract the session ID, I'll extract a user or a workspace or whatever I need that be custom for that particular piece of the system. And then I can feed that into this tier function. I was gonna say, well, now that I know who you are, what do you have access to, and you know, should I block you, should I limit you, should I warn you, should I send you an email, should I send you a text message, should I send a message over the WebSocket, publish something to the broker to say, you know, you're about to run out of power or whatever. But I don't need any of this yet. I don't need any of it, but I will need it, and it will be needed by any customers who are trying to build their own versions of this and host it, and you know, internally, and they want to be able to, you know, limit it. Maybe not, maybe not, but I'll need it myself, you know, because it will be running as a SaaS tool as well as, you know, an installable, downloadable product. Anyway, that's what that code is there. That's all good to go. File upload. All right, so some of this stuff is basically when I was changed the compressed what's it called? Transparent. That's what I was looking for. That was the word I was looking for. Was transparent. The transparent compression and decompression algorithm that happens through state management. I need to rewire that stuff up. So if you remember me talking about where are we on file upload, this isn't one of our services. It's a service, it's a file upload service. Remember, services use managers, and if I can just collapse this down, I'll zoom in a bit better here. Yeah. So, excuse me. You can see previously, erroneously, that we were using os.writefile. This means that we're using the operating system. This is part of the standard library, but that's wrong. That we shouldn't be writing files directly from the service. So I think this was AI driven, but it's based off of templates I've already created. So it's most likely something I did, and this probably exists in other places we need to fix at some point. But this is wrong. This is not what it should be. It should actually be running through some manager here. Now that's what this state where I compressed file is. It's effectively wrap that, and even then, I mean, No, this is fine. This is fine. We are still doing it through state. I want state management run through the state module essentially, so it is doing the right thing. Anyway, there's a few of these changes where we need to go and undo this. Where we're using the standard library and then replace it with our abstraction that will provide the compression underneath versus this, no compression at all. All right, I will take a quick break in a moment to go and grab a bite of that sandwich that my wife gave to me. And I'm looking at the project, I'm looking at this. So the file upload is good. What changed in files? Same thing in files. It's the same thing. You can see there's quite a lot of these write compressed files. Bring this in. Yeah, you can see that there's basically throughout the system where I've been using os.write file, either in state or directly in services. It should always be in state, but running fast and hot, sometimes I short circuit that, which is wrong. It's just bad design. You put all these lovely interfaces in place and then you go ahead and just wire it directly into a service. Like, what, you arse. Luckily, there's no one else reviewing the code on this. It's just me. And I don't have to worry about anyone else reviewing this code because it's not public. But it shouldn't be like that. It should be nice and clean. Anyway, this work is undoing some of that dirtiness and making it nice and clean. So there's just lots of that. That's basically what all the changes in here are going to be. If we scroll down to those are, it's those memory spikes I was talking about earlier on the beginning of the stream. This get file revisions thing here. That's why it's got like a strikeout through it, and it's grayed out. It's deprecated. You can't see that. You can't see the mouse over, unfortunately, because I'm not sharing my entire window. But there's a little pop over that says, this is deprecated. But that was causing those massive big memory spikes that we saw when we zoomed out on observability. Actually, I'll show you that. 30 days. I'll show you. Yeah, here it is. Memory use. See that big spike there? Massive 6 gig. Massive 3 gig. Those memory spikes because of this file revisions. File revisions it's designed to return just the metadata. And I've got a function that returns all the metadata from the database that has, it's a quick query because it's metadata, it's super lightweight. And then you decide which one you want to look at, and then you read the bytes in from the disk. I was reading all the bytes in for all of the revisions, so that's why it's like, oh, I need 5 gig of memory. It was even worse, like it spiked up to 15-20 gig of memory for some really large accounts, and that will still happen, and I've got to fix all of that. So it's already been fixed, but that's what that deprecated code is. So let's just get back down to, what is this? What is this? Oh, yeah. That's right. What this does is I've got a migration in place. Once if you've been using anonymous stuff, it's all kept very separate from real users. Anonymous stuff is like your stuff is going to be vaporized within 24 hours. But with users, I keep it all very differently. It's all organized. So what this does is I update all the revisions and copies and timelines, everything you've been working on. I then copy it all over into a workspace permanently. So when you log in and you've been using anonymously, all your stuff is there and it's saved, and it's now completely separate from your Scratch workspace. That's what all that code is there for. I think that's all the changes though. Every change is just going to be, see that. Read file, Right file. All of this sloppy AI slop. Because I didn't read it properly, but here is it doing it properly. Read and write compressed files. This is right. Yeah, I am happy with that. Files.go. Files.go. Yeah, same thing in here. And they change your rater. I'm just going to zap through these because it's the same change everywhere. Oh no, this is a work in progress. This is one of the reasons why I haven't released this yet, because this entire feature is not operational. I've got like an integration with GitHub that tracks and effectively mirrors everything that you've got going on in GitHub, and it allows you to make changes outside of Git and track those and then commit them to Git. And then you can see all the changes being made in the tree. So this is a quite sophisticated like versioning, tracking, shadow tracking system. It's not quite ready yet because it's not quite operational. I'm still getting the basic mechanics of other things ready, but it's pretty cool. And we're very valuable when it's there, but it's not ready yet, and I'm in no rush. If it was easy and possible to do what I'm planning on doing, somebody else would have done it already much better than me. And they haven't yet, in my very humble opinion. This code here, yeah, you need to not be touched. You're not ready. In this is still... This code here is not ready either, but I haven't made any major changes. So let's just leave that. Handlers. This is my rate limiting handlers. So, oh man, that's massive. Hang on a minute. I've made this too big. Let me, there we go. Okay. Hopefully that's a little easier to see. Okay, so this is still basically just setting up our rate limiting handlers, like what to do when you hit a thing. And right now I've got a couple of interfaces that I wanted available. So when you're limited, when something like when you're trying to hit the API and I need logic to do something, like this is where I'm going to put it. Like there's nothing in here for me to do right now. But I'll send an email or an SMS or something like, hey, you're blocked, as well as, just saying a notification, or a Slack message or a webhook or whatever it might be, whatever you need to hook into to say, let me know when I've reached it, so I can update, whatever. Same with on approaching. Like this is important. Like you're getting close to the limit. Like you've all seen it with AI. You're close to your daily limit. You're close to your hourly limit. I'm going to cut you off. It's that. And having hooks in there to be able to do that. Again, I don't need anything. That's why it's all future. But I need this hook. I need this mechanic in place for when it's time. So there's that. How do I block all of these people that come in here and try and sell viewers on Twitch? How do you block that? So annoying. All right. And the same with blocked. Like you've abused it over and over and over again, and we've warned you. You keep doing it, and you haven't paid or upgraded or whatever it might be, and you're blocked. And then you'll get a notification again saying, hey, you're abusing us. You're abusing me. You're abusing my service. Please stop. Again, I don't know if I ever need that, but I love having all these hooks in place when it comes time, because I've already done the thinking and I've already put them in place. It's rather than having to do it from scratch right there and then. So this is all fine. The handlers is fine, and the model is database backed. I don't believe we're using this yet, but this is what we're storing in the database versus in memory. Move on. Rule sets, same thing. Read decompress file. Service config. This is so my bunkhouse configuration is driven by Viper or environment variables or a config file. But this is where I kind of keep everything, like my hosts, keys, tokens, app IDs, credits. This is how you configure. You want your platform to run, like free credit. Do you want authentication? Do you want people to be able to log in? Here's all the different managers I was talking about. These are low-level managers that access the local. That's the design anyway. As you can see, I've bypassed some of it in places. And then these are the services that use those managers that I was mentioning. And there's a few of them. There's quite a lot of them, actually. For a little platform like that, it's quite a lot. And then these are just very different configurations. And these are keys that I use, things in the database, things in cookies and stuff like that. Can be changed. Everything in there, everything in here is fine, except the only thing that's different is we've added this HTTP rate limiting. And that to allow us to turn on and turn off rate limiting. I've still got that code commented out, so it doesn't matter what this is set to at the moment, it's going to be ignored. But in the future, we'll be able to turn it on. So that's what that is. What am I looking at here? Service config. Yeah, we're not touching this one. There's stuff going on in there that I need to look at. And in the timeline service, I'm in the middle of working on this, so I'm going to keep that as is. It's in progress. Actually, what has changed in here? What is different? Where is it? Is it here? Oh no. Okay, we can. No, it's not a work in progress. Yeah. It's not a work. This is not work. This file here, this shared linting. This is. I'm in the middle of doing something over there, and I'm not touching it for right now. Here, if you think back to yesterday when we weren't watching, but if you go back and look at the stream, we were. You know what? I'll just boot it up. I'll boot it up because let's boot the platform here and just run this. I'm gonna run it. Let's run it. It's compiling. See that down there? Compiling. Over there. No, over there. And then I need to alright, so you can see that. Let's boot it up now. Everything's rolling. You can see things the bunkhouse. Welcome to the bunkhouse. Alter tables. Yeah, you shouldn't be doing that. There's something weird going on there. I'll come and take a look at that in a minute. I'll get Claude looking at it. But it's running, and I'll show kind of where we left off and what we're going to be working on once I've got this code committed, or at least getting Claude to take a look at. So that's running. The other thing I need to do is start the front end. So I'm going to come up to my WebStorm over here. So there's a message in my Discord from Founders Mind AI. Sorry, I wasn't looking at that. I've been looking at the other chat stream. I apologize. Talking about cannabis, neurodivergent liking cannabis. Yeah, it's. I'm not going to go into too much depth, but it's changed my life. I didn't try until I was in my early 30s, and blew my mind when I started using it. You know, first of all, in the literal sense, very, very bad experience. But no, what I find is a lot of the time it allows me to walk between my conscious and my subconscious. Being stuck in my subconscious, you know, you don't really get to be in your subconscious. You don't have any control over it. You can't walk into it. You know, it just appears. Oh, I see. Okay, yeah. Well, let's not talk about that then. So there's a message here talking about on YouTube and talking about herbs. So let's. Oh, I see. Yeah. Mention it on stream. Yeah. Okay. Well, let's talk about that. But what I've noticed is we'll remove the word from the stream just so it doesn't because you know it's not legal everywhere. It definitely it's legal where I am. Channel plummeted for 6 months. Well, that's terrible. Yeah, terrible. Sorry to hear that. But anyway, I find that it allows me to jump between conscious and subconscious, like daydreaming whilst thinking, and being conscious of the daydream, versus being, you know, staring off into space. You're staring off into space, but not particularly, you know, if you're not, unless you're absolutely blasted. But that's a whole other story. But anyway, back to the code. The code is what matters. The code is what is important. It's medical in Poland. Oh yeah, yeah, and France as well. That's good. I think it's changed. Europe is changing. Europe is changing its opinion on it. You know, it's going everywhere's going backwards on things like alcohol, and obviously cigarettes. No, terrible. Anyway, back to the code, and I want to take a bite of my sandwich. It's getting cold. My coffee's getting cold. This is enabling the floating sidebar. This is actually, I was in the middle of getting my code back up here. Where is my WebStorm? And I'll bring this up here. It's my cowboy components. Yarn dev. Yeah, it's booted. It's booted now, so we can bring up locals. Come over to Chrome. Here's my local version. Here's the local version. And what we were looking at yesterday is this breakdown. It's this. So this is the Markdown report. We've already worked on this. I'm happy with the way it looks for now. This is a new feature that's coming very soon, and we're backporting all of this to Open API changes as well. But you know, we've got a diff view and we've got a change report, as well as all the individual change items and a graph. But anyway, this is what it's rendering. This is table. Whether it renders over here or it renders on the top, that is what this Go code is actually about. Over here is this enable floating sidebar. That's what that configuration is, and that is what we need to commit. Timeline service. All right. Thank you for the compliment on my UIs. Yeah, it's, you know, I see a lot of, for example, I'll just do this very quickly. Just very quickly. I see a lot of corporate, you know, trying to build like large scale, fast, you know, things with very large amounts of data in them, and like even, you know, I work for a company that's guilty of it. You know, we're trying to build these really fast systems that respond really, really quickly, and you know, you've got all this kind of stuff all over the places. There's so much data in here. There's megs and megs and megs and megs of data being loaded, but it's snappy, it's fast, it's responsive. Everything moves in the way you want it to. There's no delay, there's no jittering, there's no rent. Look how quick this is. Look, this is build. Oh, hang on, asking for diagrams. Let's reload that. So bring that in. Where are we? We were in the Explorer. Focus view. Look at that. Focus view. This is another feature that's coming, and I haven't done this. And hide the ancestors. Exit the focus. Anyway, I'm getting obsessed now. I'm getting obsessed. I love building UIs. I love building UIs because I love building the systems that enable the data that powers the UIs. On that, I'm just going to pop off for a minute, grab a mouthful of coffee, buy a food. I'll be right back. Okay, yes, we are back, and I have just had a whole McDonald's sandwich. It was good. Sorry, I'm trying not to burp on the microphone. Comment here from WebMDPL. Is that why Golang is preferred? I was curious as why it's so dominant in your code versus broadly recommended Node plus Next or trends for Rust. Yeah, so I'll give you my opinion on all of this. I've used Next. It's nice. It's a nice tool. I love TypeScript. It's great. I am not a fan, never will be, never have been, don't want to, of building JavaScript on the back end. I don't think it's a good idea. I don't think how fast you can run JavaScript is the benefit of running JavaScript on the back end. It's a technology that's primarily been designed for the browser. It's a browser scripting engine. It is not designed for large-scale application development, in my very humble opinion. Rust, absolutely, but really Rust is specialized for real-time, right? If you need real-time, that's what you use. Real-time, what do I mean by real-time? Real-time is any system that can't have a stop-the-world moment through garbage collection. So the way the garbage collection works is it literally, if you do it on a nano scale, it'll stop the world, collect all the memory, and then restart the world. The JVM does the same thing. Any garbage collection language kind of works in the same principle. You can break that down and have the scheduler kind of stop the world in chunks and segments and things like that. So no, even, if you're using Next, why bother with Golang? And the whole point to Next is that it's a full stack framework. You've got your front end code, your back end code. But Next is, it's designed to blend the world of front-end React and server-based React. And it's very good if you're into React. Yeah, it's great. But again, I just don't believe that the right choice for large-scale applications or for things that are going to run in a performant way, I just don't think it's the right choice. I'd rather have Java. I would literally rather run Java than do that. But you don't have to run Java because we'll go. And I don't need to run Rust. Some of the tools would probably benefit from Rust, but Rust is I think it's a specialist tool, to be honest. It's specialist. You need that level of performance. But then again, I'd say, well, why not just use C++ or C at that level? C++. That's probably where I'd recommend people focus. Rust is great, but there's way more C++ programs out there than there are Rust. That's for sure. That is for sure. But is that the scaling problem of apps made of Next plus Node who then need to migrate to Rust Golang when they suddenly scale and run into issues? Well, the vast majority of applications never get more than just a few users, right? I'm talking about the only times this needs to be a consideration is if you've got actual paying users or actual users using the service. And for the most part, most products never get past the, hey, I built a thing, I built it, they will come. No, that's not how it works. But when you do get to scale, there's plenty of applications out there that are written in TypeScript that are just fine. And there's other people out there that will disagree with me till the cows come home about JavaScript performance and you can do this and you can do that. I was like, yeah, I know, it's great. JavaScript is great, but it was designed to be running in a certain place. That's where it's designed. And yes, you can run it through Node, and there's a load of great stuff in Node. And Node, people didn't like Node, so they created Deno. And then people didn't like Deno, so Jared Summer, I believe his name is, came up with Bun. And people don't like Bun now because Bun is building batteries in. So database drivers built into the standard library. You need S3 storage built into the standard library. Redis, standard library. And people are like, well, that shouldn't be in the runtime. That shouldn't be in the runtime. And then we're going to see a fork again. We'll see something else. And it's just like, why does any of this matter? Why don't you just you could have this without worrying about any of that? You could just have this built in Go or Java or something that actually runs the internet. People actually build businesses on. Not, oh, this is cool. Oh no, that's really cool. And it does. There's a lot of that. This is me just be kind of poking fun at it. There is a lot of tools out there, a lot of businesses that are hugely successful that run on top of this stuff. It's just not how I would do it. It's not how I would architect it. So I choose Go because it's it's kind of in that squishy zone where it's fast enough. It's fast enough to be used for mission critical, super high performance applications, and it's simple enough that anyone can pick it up in a few days. And that means that with such a reduced vocabulary, you've got to be very specific about, or there's only so many ways to skin a cat. In other words, so you can only do things in a certain set of ways. So when you're reading the code, it's like, oh yeah, I understand this pattern because there's only so many ways to do this pattern. I really like that. It means it's a little bit like the difference between Europe and America. And what do I mean by that? When I lived in England, every shop I'd go into to buy something and try and put it in my house, it wouldn't fit. Nothing fit. Nothing. The faucet taps wouldn't fit on. The screw threads were different, or the pedestal was set at the wrong height. They wouldn't fit this piece or that piece. Everything was built ad hoc, one-off. Nothing to standards. Nothing to spec. And all the houses were built at different periods in time, so everything's different heights and nothing. Just nothing. Nothing worked. Versus when you come to America and everything fits. Everything's built to standards. Everything. And he's like, I just go to the hardware shop and buy something for my house. And you can take it home and install it in your house and it fits. Amazing. Amazing. And that's kind of where I'm going with this. That's the difference with TypeScript. Python is probably the word. Python is Europe. If you want to get anything to work in Python, you need to import this and import that. We need to use this version of Python. Oh, it doesn't support that point version of Python, and that library doesn't support this. And you spend half the day getting your environment set up with Python. It's like nothing fits, nothing works. It's the most awful experience on planet Earth for developers, Python. Yet it's the most popular. Why is it the most popular? There's the machine learning thing and the AI. Why? It's not because Python is more efficient. It's not because Python is a better language. It's because it's simple. It's easy. It's easy to teach. It's easy to understand. It's so forgiving that, it's like, it's even lazier than PHP. It's even lazier than PHP, and that's a hard thing to do. Python is more forgiving. That's why it's taught to children. That's why it's taught as a first language. And it's versatile. It's also slower. It's slower than arse, man. It's terrible. I hate it, but it's also brilliant at the same time. It's great and awful. It's a blight and a blessing, if you can have such a thing. Yeah. I'm just going to tell everyone in the Discord the stream is live. It is live, by the way. Should have mentioned that. I should have mentioned that earlier. Where's my monologue? What is going on? Oh man, 6. What's going on? There's a keystroke problem going on here. Wow. Look at this. You can't see it. Let me put this over. I just started up my monologue here. I just started it up. And this isn't me. Look, I'm not doing it. It's not me. 666. That's not ominous at all, is it? No, that's not ominous at all. What is going on here? What is going on here, folks? Does anyone have any idea why 66666 is happening all of a sudden? That's something is pressing 6. Is it my keyboard? Let's turn my keyboard off. Well, it's not my keyboard. It's not my keyboard. I don't know what the hell is going on here, but I can't even type now. This is nuts. This is nuts. What's going on? What the stop, man. What are you doing? Let's quit out of here. Quit. No. I have no idea. I have no idea. Thing is, if I come over to, wow, maybe this might be a ghosty thing, because if I come over to, where are we? We're go back to the Go code. This is our review. I come in here. I'm just hello. Oh, I can type any old crap. What the? What the? Oh my god. I don't know what is going on. I'm gonna exit out of I'm gonna exit out a couple of apps here. Something's going mental, and I don't know what it is, and I can't do anything right now. So let's exit out of some of these things. Exit. Something is. Let's exit out. I have no idea. I got no idea. I might have to go off stream here for a minute, because my machine is absolutely freaking out. It's like, like clicking, like, I'm not getting, this is just absolutely mental. My machine is going crazy. It's never happened before. And I don't know what is causing it. Let's go into the keyboard here, system settings. I can't even click anything. What is it? Oh. Figured it out. Oh, I'm such an idiot. I am an idiot. The problem, my friends, let me bring up my things I've removed now. I've just removed a bunch of things on my desktop that removed a bunch of things from my desktop. Got to turn my keyboard back. I've got to turn everything back on now. The problem that I had was I have another keyboard, and I moved my Stream Deck over the keyboard, and it was just ever so slightly touching the number 6, ever so slightly. That meant I had 2 keyboards fighting for attention. I am an idiot. Now I can't see chat. I have to delete all my chat windows. Oh my goodness. Alright, I can see chat now. Man, that was dumb. That was dumb. Anyway. Just delete all that 666. There's no such command, is there? No. Let's go back to Claude. And now that we can close that code down. Man, that was weird. That was an adventure. That was an adventure. Timeline service is good. Shared linting I'm not going to touch. In the Go mod, what do we change? Oh, we can't commit any of this. This can't go. This cannot go in there. What this is, any other changes? No. This here is essentially saying, instead of using this module from GitHub, instead of downloading it from, from the internet, use this local version. So that's how I can work on all my different versions of different code bases and have it all run, in one app. It's a pretty common way to allow you to mix and match, modules that are public, that are downloaded from GitHub or other places, versus having your own local copy of that code, and you want to run your own code versus that module, but you don't want to change all the imports because that would be a nightmare. So you can replace the import with your local version. So that's what I do. That's how I keep all of my different code bases. I'm building on a feature that touches like 5 different repos. That's how I do it. I put everything kind of locally. Everything is locally structured. So it's kind of like a mono repo, but it's not a mono repo. It's a poly repo. Poly repo versus mono repo design. Big topic, not for today. But yeah, I use a combination of both. It allows me to operate like it's a mono repo. So everything is in one folder. But it's not. Those are individual repos that are separate, sometimes by account. So they are not. They don't exist in the same place in the internet, but they exist in the same place locally, and that's how I source it out. All right, so let's move on. I think we've got enough stuff in here. So I need to bring up my monologue. I lost my monologue. That's where it was all started. Monologue was going mental at me, and then I realized that I had a keyboard problem, and I'm an idiot. Reviewed some of the code that we've added for rate limiting as well as compression, and all looks good, and everything's running and everything is working. So we're going to move on. All right, I'm going to commit that. And all we've got a list for the things that I'm not going to touch yet because there's stuff in here that is not ready. Hence, I'm not sure if we can, let me zoom in on this. You see that? Not ready. It's not ready. It is a big pile of mess. And I've got various different ideas and techniques I'm working on in there. And it's for a part of the system that is not even remotely ready yet. I'm just leaving it there for the time being. It's not doing any harm. It's not even being used. I haven't wired any of it up because it doesn't work. Not yet. It will work. I just haven't had the time to fix it. Right, so the next thing is I want to look into a problem that I discovered yesterday, and I'm not entirely sure why it's happening, to be honest. I'm not entirely sure where the problem is coming in. I know it's because I was debugging some stuff, and I was changing some stuff around, and I think I walked away from it mid-hack, and it's not operating the way it should do. It's missing some stuff, and it's based off of the way that we're doing the graph, and this is really, it's trying to fit in new workflows to one data structure. So the nuts and bolts of it, I'm going to bring up Chrome here. So this is this diagram here is actually a tree, right? This is rendering out a tree data structure. A tree is like a very, 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 very specialized form of a graph. a graph is not a tree, but a tree can be a graph. Very, very specialized form of a graph. Like it has kind of termination points and it has a root. A graph does not have any or either of those. I mean, it can have some termination points, but it doesn't necessarily have termination points. But a tree does. Anyway, this is a tree, and you know, if you know what a tree is, it all makes sense. But the thing is that this data structure isn't a tree. It's not a tree. It is a graph. And we come into this equalizer, and we turn on references. We tune it. We can actually start to see the graph appear, and we can see those references coming in. For example, problem, you know, is referenced by all of these. I mean, we're sitting with. So problem comes from components, which has schemas, and all these other objects reference problem. Right? These are edges that are references. They're not like a hard edge, which is, you know, in a tree, like it's a definitive line. No, it's not Apple. It's not Apple. It's not Apple at all. That was so. The comment was about the 66666 crazy devil that took over my machine. It wasn't Apple. What's going to do with Apple? It's me. I'm the problem. I was moving something around, and I've got a keyboard in front of me. It's a split keyboard. I'm trying to use when I get time. I'm terrible at it, and I just let one of my cables was laying over the top of it, and he's got in the way. And I'm sorry. I'm an idiot. But this graph here is all generated by code that I've created and tuned over the last couple of years. And it works great for the most part. There's some places where I needed to do different things in different ways, and building edge cases in for that and workflows. And I've got to move this graph now in different positions. So for example, you see this here. All these things are pointing to this problem. If I click on problem and I bring out this view here, I've got this focused view. And what that does is that rebuilds the graph and just shows everything from the problem's point of view, which means it's going to show you all of its downstream properties, which are here. It's showing you it's got all of these different elements to it. These are in fact schema properties. They're properties of the problem. Title, type, status, instance, and so on and so forth. And then these are all the things in that reference that node in the graph. So you've got to build that, which is complicated. It's a different way of imagining it. Then you can actually get this, hide ancestors, and you can just see the effectively just that object in isolation, and you exit out and come in there. And then we've got this other feature here called diagramify. I love stupid names for things. This is called. It's based off everything here is based off the Doctor, so it's got a kind of quirky name. Doctor Who being the inspiration for behind it. You can't see because I've got a green screen up, but behind me I've got a bunch of like Doctor Who toys and stuff on one of my shelves, which I'm doing regular day stuff. You'll see, but not today because we're doing code. Anyway, the problem is in my diagramify, not my focus view. All that stuff's working brilliant. I'm very happy with it. All looks great. Like here's a shortcut. I don't know if you can see that. Let's zoom in. Look. It's a shortcut to the focus view. You can just click on that on any object, and it's going to turn that on and bring you right to that point of view from that object. This is a lovely feature. I can't wait to make it public. It's almost ready. It's almost ready. It's been ready for a while, but all good things. All good things. Now it's this. It's diagramify. So let's pick a schema. Oh, I don't know. Trip. And looking at trip isn't a very interesting. Ignore all these KK things. These are little flags I've left in because I need to come back and look at some of this example code because it's wrong. And every time I look at it, it's like, why is that cake? Oh yeah, I need to go and fix that. So I do that a lot of the time. Is I leave really obvious markers everywhere. That's horrible. It's like a really annoying something in my side of my neck, and I leave it there. So I go back and fix it. I know I need to go and look at that, but I'm too busy, looking at other things at the moment. So instead of like always keeping a list, I've got my notepad here, my big red book of mistakes, and I use that a lot. But this is just another coping technique for me. So the issue I'm thinking about here is, for example, you see this booking payment. This is actually the structure of the object. We've got this. Let's make this a bit smaller. We'll just get rid of it for a second. So we have this booking payment, and it has. Let's take a look at the code. Where is it? Booking payment. Here's the code. You see that booking payment? It has properties of ID and amount and currency. There's 3 properties. No, and source. 4 properties. And source is a big object, and source has its own a polymorphic inline. This is all inline. It's not references. It has its own polymorphic. Any of this. It could be this, or it could be here. There's all this other stuff down here. So it's like a bank account or a credit card. It's basically it's either one of these. I hate any of. I hate it, and one of, all of is fine. Anyway, it's got a bunch of stuff in here. So there's what we should see at a minimum is we should see, if we come back up to the top, wherever it was, problem. Where were we? Booking payment. There it was. Booking payment. There it is. Booking payment. If we're back up here, here it is in the tree. We jump there. We should see the source and then bank account and card. Like we should see this in the diagram, and the diagram is what it's going to do is it builds there's a new feature I've got called the diagrammatron in Doctor, and this will diagramify via the diagrammatron, and we bring it out, and yeah, it's right, but it's missing. It's missing this and this, these 2 polymorphic elements. It's missing the polymorphic elements, and it wasn't before, or I've never. I think it has, but it was missing the polymorphic elements. So I built this code about 2 months ago, and I can't remember what I was doing because I've built like 10 other things since then and fixed God knows how many bugs all over the place. So yeah, I need to load all this back into my brain. More importantly, I need to get the AI to load this back into his brain because I can't remember. And this is going to exist. This is a back-end thing. The logic for all of this, for generating all of this stuff, everything, the logic for it is built in the back-end. And that's why it's all exposed via an API, so you can build any user interface over the top of it in any implementation. Desktop, CLI, doesn't matter, because it's all API driven. But what I do is I'm rendering all of that data that has been computed by the backend and then sent over the API. So here's your computed data, render it like this. That's what I'm doing here. There is some stuff in here that is doing computation. I do that via web workers. That's a whole nother conversation. I'm not talking about that today. But I want to figure out why my diagrammatron is getting it right. It's right, but it's got source, and source is an object, and this is it's not right. It's not right. This is not right. It's not right. It's not right. Not right. Plus we've got some weird rendering issues up here. Those aren't as important as getting this right. So I need to have Claude go and take a look at it. Let's go and talk to Claude. Hello, Claude. Hope you're doing well. Today we are looking in the Doctor. Let me just make sure, because I've got Claude running at the top level of my repository. As I was mentioning earlier, my mono repo that's really a poly repo, but everything it looks like it's a mono. So it all sits off my pb33f top folder, and every project is underneath it. So we're looking in the Doctor, and what it does is, because I've got my main memory file at the root, and then I've got all my sub memory files, in each individual project. I've got custom memories for each individual project that then get added to an addendum to the main root, the one that I have. And I like to operate like that, because it can then move in between the repositories and look at the code individually, and then because it's then zoomed out versus being in the individual projects and have the you've got to go backwards. And I find that it starts doing stuff in temp all the time when I do that. So I keep it here because it's just a little cleaner, it's a little easier for the agents to kind of navigate through the multiple different projects and code bases. All right, so we're looking in the Doctor. Actually, it's the diagram. Oh, is it diagrammatron? Let me have a quick look. Yeah, diagram. Yeah, I spelled it in a strange way. Diagrammatron. Yeah. And we're trying to investigate a problem with some of the rendering and some of the things that are being missed. So, for example, here is a snippet of a schema that I'm trying to generate a diagram of. What I'm going to do, where's my terminal? Why can't you see my terminal? What's going on here? Oh, dear. What is going on? Terminal 1. What's going on, man? What is going on there? Sorry, I wasn't paying attention to the live stream, but didn't swap over to my correct. It's like a blank screen. Get rid of this. Get rid of this thing here. All right. Yeah, I don't know what happened there. So I'm about to ask Claude. As I said, I was just mentioning it. I'm going to get a snippet of the schema. So what I do in Chrome is go to Chrome, and I need to close this off, and then I come over into the OpenAPI spec, and this is the booking payment. Basically, this is just this is just a JSON schema from the train travel spec from bump.sh. Who until very recently was a sponsor of Princess Beef. Thank you very much, Bump. Appreciate everything you've done. So we've got the booking payment, which is, there's no references in here. This is all that I can see anyway. So there should be a nice rich image, whether or not, but we're missing the polymorphic stuff, which is annoying. And it was working, or at least I think it was working. So I'm going to copy that out. I'm going to go back to Claude. I'm going to paste that in. And as you can see, this is the booking payment schema. Let me change that to make it correct. What's going on there? Now I want to go back into Chrome, and I am going to pull out that diagram. Whoops. There's another bug there. I want to do card. Card is giving us a hard time. Bank account. Same thing. Excuse me. Both of those are giving us a hard time. Both of them will come back. Actually, no, I think this is relevant. Is it relevant? So let's diagramify the booking payment. All right. I'm just going to copy out those. I'll copy out one of those error messages. Let's go back to the Go code. So I've just copied in some of those things I'm going to use to give to the LLM. After I'm going to ask it to read all the code. First of all, I'm going to need you to read all of the code to understand how the diagrammatron works and how we generate Mermaid.js from the existing model. Go deep, ultra think. It never spells it right. It never spells it right. It always does that. Let's give us an ultra think. All right. But it's missing all of the polymorphic data. It's not rendered at all. And if I try and render out either the bank account or the card, I get this. So can you take a look at the code, do a full analysis, and build me a complete report and a strategy of what is going wrong and why this isn't happening and what was changed. Take a look at the Git change log and see what was changed and what might be causing this so we can fully understand the problem. All right, Claude, we're going to do a thorough investigation of the diagrammatron. Let's see how it generates our mermaid.js. Because it's kind of busted. It's kind of busted, Claude. It's almost there, but it's not ready. My family's been suffering with a cold this last week, and it seems to be just hitting my face right now. Oh, today. Today's my day. I can hear it in my voice. It sounds like I'm getting a cold. Great! What do we want to do? Yes, I want you to find it, Claude. Yes. How are you getting stuck here, Claude? You haven't even got to the tool. You've 100,000 tokens. Look at that. Done. Even the wrong folder again. So we're using Opus 4.5. This is the newest, greatestness from Anthropic. Forging. Come on, Claude. So while we're waiting for that, while we're waiting for Claude to do something, let's go and take a, kind of look at some other things just to verify. So if we do wrapper collection, yeah, it's definitely missing like links, XML. What about problem? Problem. There's nothing in there. Station. Nothing in there. Really. Wrapper collection. Nothing in there. Need some. We need some bad request. Responses, bad request. Okay. Bad request. And content. Here we go. Diagram before this one. Schema. Type. What is that? What is that? Reference is the problem. We should probably do a better job of rendering out that. Well, let's see what's going on first. There's all kinds of quirkiness in this that we need to take a look at. It's almost right, but it's missing some stuff, and it wasn't missing before. The references being a particular pain in the ass because not that it's a hard problem, it's just the way that you've got to twist this machine in I've built it to be twisted in different ways to make it render out things in different manners, like different graphs and different, like I've been showing you earlier. It's complicated, and the polymorphic and the just circular references and finding and locating, it's stuff that gives me nightmares. Yes, I want you to proceed. Okay, Claude is talking to me. Let's go back to Claude. Yes. The test passes using references. Yeah, I know, there's nothing wrong. There's exactly the user facing, which is inline any of, not variance. Yeah. Spend a lot of time working through references, so it's messy in some places because the rules like do and don't apply sometimes. Open API and JSON schema. The chaos that some people create. Although Vacuum is really, we've deployed Vacuum in Splunk. And Splunk security, more importantly, is where my influence leads. And our APIs are getting cleaner and cleaner and cleaner. And now it's like they come out of the gate like super high quality, driven by linting. And now we're building tools that use those specs, and they have to be super high quality. One of them breaking changes and all that kind of stuff. So it really does. Once you get this stuff in, once you get this tooling into your business, or tooling like it really will make a difference if you use it effectively. It really will. It'll change everything. It's the start. It's where the river begins. It's the stream. It's not even a stream. It's a trickle. It's a drop. It's a drop from an iceberg, not an iceberg. Glacier. A glacier in a mountain. All right. Enough. Shut up, quobix. Shut up. Found the root cause. Only one class is rendered. Yes. Of course, the banking account, the inline schemas are completely ignored, which is wrong. This is totally wrong. It's totally wrong. Yes. 0 relationships are created. All right, let's go, Claude. What you got? What you got, bud? What have you got, my friend? Tell me all about it. Tell me. Interesting findings. Yes, I want to proceed. Yes, I want to proceed. Cloud. I want to figure this out. Why? Critical finding. They both get the same class ID. Oh, look at that. Oh, dear. Buh. What's going on here? I can't tell yet, but my guesstimation on this is that we have I was simplifying naming. It was simplifying naming because the names it was generating were crazy, and I think it might have oversimplified a bit too much to the point where we've lost too coarse now, and that coarseness is creating problems with conflicts. We need to make it a little bit more granular in the sense that we can have like subclasses of subclasses of subclasses of subclasses and so on and so forth without having this problem here. After the fixes, the following should pass. And want to implement these fixes. Let's have a look, mate. Let's have a look. What have you got? What have you found? What have you found, Sunshine? Have I lost my Discord again? I have lost my bloody Discord again. Good God. Maybe I didn't start it up. That's right. I didn't start it up again. After I had my crazy 666 experience. I'm going to leave that there now. Sorry, I'm just screwing about with my desktop here again. Getting my Discord up so I can see all the chats. Back to what's going on here. Issue 1, mate. Issue 1. Here we are. Let's have a go. Here's our comprehensive, and let me zoom in a bit so just in case you are following along, or you want to take a... Oh, no, don't do that. Oh, man. That's annoying. Every time I zoom in, it jumps to the bottom. Okay. All right, well, it says a comprehensive diagrammatron analysis reports after deep analysis. So I've identified 3 interconnected bugs that cause polymorphic inline schemas with inline definitions not written properly. Okay, so this is an edge case, but it just so happens to be everywhere through this spec. Because I got the references handling pretty good. Property level inline polymorphism is not handled. Oh, I guess we never did it. Inline variants will need different handling, but typically one of uses refs. Yes. Result. When your booking payment source has inline only variants, the card and the bank account defined inside the property, they are completely ignored. Okay. Issue number 2. ID collision for inline polymorphic variants. We have a get class ID function. This is something I was talking about when it does simplification via names. It checks for schema name but not title, so it falls back. Okay. Yeah. Card, bank account. Yeah. All right, so what's failing here is it's actually, I told it to use JSON path to define things, and this is, genuinely a unique JSON path. The problem is if it's trying to create a sensible name out of this, you can't use that. So it's obviously got to use the schema booking payment, but there isn't actually any way to determine the name beyond that, beyond source. So anything inside source is going to get lost, and so that's why it's not rendering out anything at all. That's what we're ending up with. Second variant is ignored. All right, so that's a simple problem. And the title field is not used. They have proper card titles. They're not being used. The ID is not using the title. Okay. Evidence from testing. I created a test with the exact schema structure using the exact snippet. Found there were no relationships. That's exactly what we're seeing. It's exactly what we're seeing in the diagram. Just in case you have forgotten already, I will bring it back up. Let me just get out of this. Get out of this view quickly. All right, let me bring this back out for you. Booking payment is indeed a rich. It's got bank account and card defined as inline schemas via polymorphism, but it is not rendering them out in our Mermaid.js. That is what it looks like, and that is what its Claude is telling us all about right now. And the Mermaid parsing error is the error they mentioned. Is because when you try and render card or bank account individually, not through the parent schema, the class is created with incomplete or malformed Mermaid syntax. Alright, strategy to fix. Fix the inline variance in handle property polymorphism. Okay, so it's the if else. It's the else statement that we need to implement, because we spent a lot of time over here and we didn't do much over here. That's the problem. I was like, yes, it works, and I moved on to the next thing. But it doesn't work. It's not finished. That's why it hasn't been published yet. It's not why it's live. How are we doing on time? 2:15 hours in. We have an hour-ish left. Ish. Let me check my other computer Rotron over here. Ooh, no, we've got a little bit more time actually. We've got an hour and a half. Actually, no, it's not an hour and a half. I need 10 minutes to freshen up, powder my nose with makeup. Not really. I don't really wear makeup on my nose. Not that there's anything wrong with wearing makeup. It's just not for me. Where are we, Claude? Oh yeah, we're looking for the code. That's right. Looking through code. So it's asking us about including any of the index. Ooh, hang on a minute. So fix one. Total check. Yeah, the index is important. But it shouldn't be in the type. We shouldn't be rendering that out, but it should be in the ID, which is used by Mermaid internally. Any of, one of. Well, we need to make sure that in fix number 3 that we're also have we considered all of as well. Fix 4. Create the polymorphic placeholder for inline variants. Ensure that inline variants get unique IDs. Yes, that's important. It's a new helper. Okay. Alright. In fix number 3, can you ensure that you've also considered all of? No, it's not all of, it's like that. All of. In addition to any of and one of. Text number 3. Why would it say text number? Did I say text number 3? Did I say that? I don't think I said that. It's not. I said fixed number 3, didn't I? I swear I said fixed number 3. Maybe it didn't. Maybe it didn't. Oh, sorry. I was looking at Discord. Do I want to proceed? What you're doing? Oh, yeah. Yeah, I'm gonna go back and read what it is talking about. For all of yeah, works correctly. Yes, that's because all of is good. All of is essential. The inline all of members don't create separate classes, they're flattened. Yes, that's true. Yeah. Okay. Okay, Claude. That is all correct. Yes, it is correct. All of does and should flatten in the rendered schema, to be honest. That's exactly what it should look like. It's any of, and one of should be burned. I might actually create a rule in hard mode that says, why are you using polymorphism? Oh, because we need it. I know you don't. Use all of. Oh, we need for inheritance. I know it's tempting. You get there and think, oh yeah, we just add in one of, or one of. All of makes sense. Hey, Luke Hager, how you doing? Hello. Nice to see you. Nice to see you on the stream. I haven't. Sorry, I didn't read your response there on Discord. I'm just looking at it now. This is the common mark part of OpenAPI YAML being properly tokenized inside just an editor instead of all plain text. Oh, I see. Oh, that's what I'm looking at. Oh, you got the markdown in there. Sorry, I didn't realize. I didn't realize that's what you were doing. Nice hat. Yes. What hat am I wearing today? Atari. Yeah, I try and wear a different one every day. I got a couple of new ones arriving. Yeah. Yeah, cool, man. Exciting stuff. Looking forward to seeing it in action. All right, we are with Claude at the moment, and we're trying to get our polymorphism working. For all of, there's a design question. Should inline all of members with titles be rendered as separate classes? Currently, flatten all of. No. Ooh, that's a good question, isn't it? Yeah, so yeah, the chat, Luke in the chat says so if you go into Discord, if you go into the Princess Beef Discord, you'll see Luke talking about some really nice features working on, and it's colorizing and tokenizing open APIs, effectively, you know, an LSP that allows you to properly understand and render out open API in a custom way. Looking good, man. Looking good. A custom tokenizer. That's hard. It's hard to do. It's hard to do right. It's hard to do well. Really hard. I believe Luke is building it in TypeScript. Should just slot beautifully into VS Code. I'm assuming that's the idea, right? Anyway, back to this design question. do we want to flatten? So right now, all of in our Mermaid JS diagrammatron is flattening out all of, because it's a good idea. That's what you should do. That's what I expect. That's what's rendered. But in a diagram, if it has a title, it means it's something that you want to clarify as an entity. And if you just consume all of the properties in, you're not. And there's a lot of them. You could have all of. You don't know which one is which without a title. If you have a title, you can distinguish that. Without a title, yeah, okay, well, good luck. Put a title in, and it should create a new diagram. But it's not right now because it's flattening it. I think I want to change it. Luke says, I've been thinking about common schemas in OpenAPI lately for things like all of, which wouldn't good to treat every schema like it was components listing. Yeah. So yeah, that's what I was right now. So just for your awareness, what we're doing is we've got this little feature called the diagrammatron, and it's rendering out booking payment, and booking payment is actually composed of any of polymorphism, which isn't working. So we're fixing a bug, but then we also have all of, and all of is much, because it makes sense. It's because it's good, but in this case, the way that it's going to render, I haven't got an example here, but it's rendering inline, so it takes that and it will just put those properties in as part of the class. So booking payment, even though it has 2 or 3 all ofs, it doesn't, but let's imagine it does. And they had titles in them like card, bank account, blah, 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 whatever it might be. I don't know, it could be anything. You lose that definition of which all of it came from, because it's just flattened it all out into properties. So that's what's currently doing. That's what Claude is saying we should keep it as. And I don't agree with it. I think it should be where if it does have a title, it should break it out, and there should be, it's a relationship there. It's a descendant of, or it's composed of. So we've already got that in a number of places, but I want to change that behavior that we've got right now, and it shouldn't flatten everything if it's a title. Right. Back to Claude. Claude, what I want to do, I don't think I want to make it, or maybe we should configure. Yeah, okay, Claude, I want to do option 2. I want to make this configurable to either flatten it or inline. So I don't want it's not going to be flatten it. Or we can show any members that have titles. If there is a title in there, then we can create separate classes for it and show them as relationships. That should be the default. If there's a title, it should show the relationship. If there's no title, flatten it inline. I can't actually hear the music. The music is coming out. It's going out on a different channel on my streaming tool. So for me, it's all silent. I'm just silent right now. I don't actually know what the music is, but it's all free stuff, like royalty-free stuff. I'm glad you like it. I don't know what it is though. Some of it is terrible, terrible. I've heard some of it and it's awful because I listened to it before I put it through. But I'm glad you like it. And yeah, we create subclasses that use extends. That's exactly what we do. Because that's already that code's already there. It's just how we're treating this particular relationship. Yeah, that's what I'm going to do, Luke. So if there is a title in the subclass, in all of, that is, not the other polymorphic ones, then it's going to create a subclass. It's going to actually create that and do a relationship. If it doesn't have one, it's just going to inline it into the properties, which is what it is anyway. That's the reality of it. But and it would be in any compiled schema at the end of the day anyway. But for the sake of the diagram, it should show the relationship because it is a it has a definition there. So we should see that, because if there's 4 or 5 of them in there, you're not going to know which properties came from which class or which definition. So yeah, it's the right thing to do. Now we're having Claude bash this out. Let's see what happens. Yeah, synthwave. I think there is some synthwave in there. I think there's some stuff in there. Creating the inline variant class helper function. Let's see what kind of a mess. Not too much of a mess though, because we can roll back pretty easily. But the bug needs to be fixed with the class problem that we have there, and the fact that we didn't even fit in the inline stuff. Yeah, I think Luke's commenting on chat about building a graph of essentially of only the polymorphism. You need to break them out and use generated titles. I spent some time thinking about this, which is why we're adding this variation in here. But I think when the more generated stuff I put in there, like for example, I'm having to generate some of these class names that just don't have loads of inline stuff. They've missed titles. I've tried to use some reasonable naming in there, like responses, for example, and how do you make this so that I can do it up to a certain point before I'm like, you know what, it adds more complexity. Then it's it's not simplifying anymore. It's now like, what the hell is that? Why is and I don't know. So what I'm doing is if there is an explicit name, use that, break it out. If not, inline it. Particularly when it comes to the schema stuff. Everything else is given like a reasonable name. Some things you can't name, like a response. Like it's a 200 response. That's JSON. With media type of application / JSON. There's no way to identify it cleanly in a class diagram other than generating a name. Yeah, it is. It's generated names are always terrible, and even people make it even worse by putting crazy operation IDs in there that are no use. In fact, they make it worse, or no operation IDs. Automatically add AI generated labels. Speakeasy had a tool that would automatically add AI generated labels for things like that. I haven't heard much from Speakeasy, and I talked to Cigar quite a bit, but I haven't actually heard from the engineers in a while. Assuming all moved on, building MCP stuff now. Open API is not interesting anymore. It's all MCP now. MCP, Model Context Protocol. Wow, we're running out of context quick there. Come on, man. Luckily, we're at the tests. Now we can swap over to Sonnet after this. Yeah, I agree. One of the things I'm going to be doing at some point is we've actually already got autofix as an architecture built into Vacuum now. So I'm going to be adding like programmatic autofix to rules, which means you can provide a function that's actually going to take that rule and that fix the whatever needs to be fixed. However, you can customize it for each piece. Yeah, so the comment is they built their own parser, their own library or libraries, and are using them for various different bits and pieces. A lot of the things they don't need for the lower level bits and pieces they don't need the power in certain areas, or they want more customization. As I've said from day one, I've always said everything I've built, it's built for me. Everything I've designed it for my use, so I can build things on top of it. And I'm super happy that other people find them useful. And I always try my best to make it clean so other people can use it. But at the end of the day, these are tools that I need. That's why they're all maintained, and that's why they're very super focused, and I haven't kind of gone crazy and branched them all out into lots of useless noise. They remain focused because I'm working towards this larger goal. A lot like yourself, Luke, with your own tool, your LSP. 4.5. I'm loving 4.5 so far. It's great. I mean, 4.1 is excellent, but 4.5 is just even better. It's just faster as well. It's great. Okay, so Claude is telling us he's fixed our inline polymorphic schema rendering in the diagrammatron. Here's what we've done. We've got a configuration option now for doing the title or inline rendering, which we can configure, which would be nice because I'll put a control in here, up here somewhere, for when that option's available to inline it or not, and you can choose to render it A or B. So you'll get control over which way you want to look at it. Then we've got our ID generation fix, which is coming from the TARDIS. Excuse me. Property level polymorphism, and this is with inline stuff that we've been dealing with. And all of sorted that out. That's that feature we've been talking about. We have a new helper. Excuse me. Does my tooling use Monaco? Yes, I use Monaco. Yeah, I mean it's great. Monaco. If you don't know what Monaco is, it's the open source. Oh, great, lovely, cool. Yeah. Oh, yeah. I'm using Monaco. Yeah. So I can. I think I'm already loading a schema in. I'm loading in. Just the whatever schema version you're running your OpenAPI 1, OpenAPI 3 or 3.1 or 3.2, it will load in that schema. But I don't think I've got any other plugins operating in Monaco. Not yet, anyway. Not yet. So this is what Claude is telling us now, that when we go and generate our booking payment, which this is the same the booking payment is going to look like. It's going to give us our different classes, and this is the Mermaid.js is going to spit out. Well, I hope, Claude, I hope you're right, because this is what I want to see. This is right. Starting with, sorry, in the chat, Luke's talking about the LSP framework he's working on, which is a Monaco plugin. And if you weren't following along, the Monaco plugin, this is Monaco right here. And I've tuned it, and it's obviously wired in for my own use cases, and I've got customizations in there for rendering and things like, all this kind of stuff. But anyway, this is just using the APIs. Luke's got a plugin that allows you to effectively do tokenization on open. Right now, this is not doing any tokenization on open APIs beyond just YAML tokenization and things that I'm custom rendering, like references. So Luke's got a plugin that will do a lot more than that. At least that's my understanding. By the way, for Opus in Claude CLI, you need to Pro or Max. For Claude, by the way, just for everyone's information, I have Claude Max, the $200 a month plan. So Max, as much money as I can give them, I'm giving them, because this tool is amazing. Amazing. It's amazing. There's no other word for it. It's amazing. And I use Codex as a code reviewer. It works pretty well for that. Man, it is slow. It's so slow that I can't use it to work with as a partner. It doesn't work fast enough. But it does a thorough job. But it's one of those things where you say, here's the thing, go away and come back when you're done. But with Claude, it's real time. It's like, hey man, hey. So I just prefer Claude Code. I just love it. And I know they've also got it wired into the desktop tool. Man, it's great. What a great tool. It's just changed my life. I have so much fun now with all this stuff. I'm just designing. I'm designing and thinking. I'm not wasting my time building boilerplate and fiddling around with broken tests and, oh no, I've updated my IDE and nothing works all of a sudden. Like, those days of pain is like, I don't have to worry about that anymore. It's just, I get emotional thinking about it, because I was such an AI denier to begin with, because it was terrible. I've had Copilot since it came out, and it's just awful. Gets in my way, drives me crazy. Luke's talk about he's not spending his own money on Opus. Yes. One of the benefits of corporate subscriptions. Yeah, we have the same thing as Splunk/Cisco. But we're not actually running off of. We're running off of in AWS Bedrock. We've got essentially our own models, so they're protected. I think that's pretty standard with how Anthropic does it. Maybe not. I don't know. So I don't even think there's Opus. There is Sonnet, but I don't think Opus is available. I'm not sure. I don't know. I have to ask one of the team. Anyway, I digress. I'm all over the place here. Let's try this out. So let's go back to the Go. Our code. I shouldn't get rid of that. Let's get rid of you. We don't need you. Let's restart. Start. And restart. Wait for it to compile. It's compiling. It's down there. Look. Compiling. Building. Platforms up. Give it a kick. All right. And then let's, where was it? Components. It was a schema. Booking? No. Booking payment. All right. Diagramify. Hey, yeah. Look at that. You son of a gun. Booking payment, bank account, card, source. There, look at that. Exactly right. Yeah, you have a good day, Luke. Thanks for dropping by. My name's Quobix, by the way. That's my name. It's Quobix. Thank you for stopping by. Appreciate it. Have a good day. I'll be here for about another 40 minutes or so. We've been going for just under 3 hours, so I'll be about another 40 minutes left in today's stream. Yeah, but yeah, look, it does look good. Look, Claude, he did it. He did it. Claude, hang on, let me get rid. There's a Z index problem over here. Let me kick it out of that view. Now you can see it better. Perfect. Does it support multiple files yet? Yes, it supports entire. All you got to do is import. Look, import URL or upload a zip. Go for it. Have fun. You'll see a completely different experience. It brings up another panel off to the side here. You see the whole file system. You can click through. I mean, it was working. It should be working. But anyway, play around with it. To me, we think. Again, this is more of this is an API product. Yeah, I'm just building this interface to show how the API works, but really you want to put your own interface over it. Yeah, go for it. Yeah, right there. Enjoy. And coming soon is all we got full integration with GitHub, and you can import your repos, and you can then see the entire history of your report. Let me swap over here and come over to the timeline. This is old stuff, but you can see like your repo and all that kind of stuff is coming soon. It's not ready yet though. Have fun. Let me go back to where we were. All right, your workspace. Here we go. This is our spec, and I want to come back to my document. Booking payment, diagramify. Yeah. Yes. This is right. People, this is right. This Z index problem is driving me crazy. Where is that? Diagnose. You're in the editor. Because you're getting in the way. You are all getting in the way here, the editor. The editor's stealing focus. That might be a problem. That might be a real problem. Maybe not. Just the editor is actually in the light DOM. The editor is coming from the light DOM, and I'm controlling from the shadow DOM. No, it shouldn't be. I'm not gonna bug and mess around with this. We're gonna review that code, and then we're gonna call it a day. Because it's a good point. It's a good place to stop. We achieved our goal. We achieved the goal of fixing the diagrammatron. Look at that. Beautiful. Let's take a look at some other stuff. Let's take a look at some other stuff just for fun. Wrapper collection. Nothing in there. That's boring. Trip. It's boring. Links. No. Let's look at those responses. No. Nothing else that's interesting. These are all boring. No, it's all the same thing. Problem. Oh, hang on a minute. I'm probably clicking on the wrong thing. Yeah, okay. That was me being an idiot. There's another bug there. That's not what I wanted. So these are all going to be the same. Let's go over here. Look at this one. Diagramify this. There's nothing in there. Links booking. There's nothing in there. Station. Let's have a look at station. No, station is boring. Booking. That's boring too. Booking payment because it's a relationship. What about wrapper collection? Well, now there's nothing in here. Like there's nothing to them. We need some better objects. We need. Take a look at this. There you go. That's more interesting, isn't it? Wrapper collection extends. So the get trips 200 response extends the wrapper collection, which includes trip. So this is what the actual schema looks like. Let's take a look at the code. This is what it looks like here. This is pretty typical. So this is why it's hard to understand and visualize these objects, because here's the application XML response type. And it's composed of polymorphic all of, which is a reference to a wrapper collection. It has some properties, which is also then a reference to items, which is a trip. And then it has its own properties, which is links, which contains more all of to links and pagination. So it's hard to see this. It's really hard to see this until, you know, you come up here and say diagramify it for me. And then like you've got this really easy to understand diagram. Ah, what a lovely feature. We just need to fix this z-index problem, and I don't feel like delving into it today, to be honest. Maybe I do. How long we got? We got a while. We got 30 minutes. You know what? Let's do it. 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 All right, I'll need a quick break though, because I've been going for nearly 3 hours. And I had to stuff my face about an hour and a half ago, but I need to go and get some coffee. It's 11:04 my time, so give me 6 minutes. I'll be back at 10 minutes past. Let's come over to here. Past the hour. All right, I'll be right back. It is raining and pouring, and the old man is snoring. He bumped his head. No, he went to bed first, then he bumped his head. Couldn't get out in the morning. Couldn't do it. I used to feel like that when I drank alcohol. Couldn't get up in the morning. Booze. It is bad for you. Don't do it. Don't do it, kids. Right. We're going to fix this mess before we finish our mission for the day. And in order to do that, I'm going to need to go into WebStorm. WebStorm is where I run on my front end. And we have Z indices problems. Let's start finding the Z index. Z index. You can't see what I'm doing, unfortunately, because it is pulling out. It's pulling out. I've got a search window. It's dimmed everything. I'm just trying to find the Z indexes, and we're going to go through these bit by bit, one by one, trying to find them all. I'll try and find them all. Oh, there's so many. I've got like such a range of them. There's like 1, CSS 10, 20, credit ticker, diagnose button, minimap toggle. Oh my god. 10, 1. Alright, so let's get some standardization going on here. 999. Details draw. Oh, ooh. Where? Sorry, I'm just trying to find where. What on earth is going on here? I'm not entirely sure I can fix. Let's just see if we let's just go back. Let's go back. Let's go back to the code. Let's see if we can fix this in. See where it is in Chrome first. So we gotta figure out why this this bar, this collapsed view that appears with the editor is appearing over the diagram. Sticky scroll, whatever this is. So let's go down something like this where we've got path stations. It's got something here. When I bring over, the draw is coming over the top of everything. As are these. So, whoops. Let's do it again. Let's try and figure this out. Try and figure it out. This is my content in my drawer. Close you up. Where's the editor? The editor. And then there's the drawer. So here's the drawer. Here's what's come out. And here's the editor. I think the editor is coming from the light DOM down here. Here. And the problem is here's all the Monaco stuff. Here's what we were talking about earlier with Monaco. Here's where it's bleeding through, it's bleeding over my drawer. It's bleeding over the drawer. This is the index issue. And I don't know why that is. The question is this shortcut, whatever this is called, it's like a breadcrumb view, which is it like it's configurable. You can use it. You can use it when you're configuring up the editor as part of the part of the API. I think it's good, but it's overlapping, or it's going over the top. And is it a z-index issue? The question is, to get rid of that, we've got to bring up some docs. So we've got to go to problems. Where's all the problems? Oh, hang on a minute. Okay, there's a weird rendering issue we need to solve there. But to see if this is actually a problem, like if we go to objects and diagramify, you see that thing is bleeding over the tray, as is these two elements here. Not that. But it's coming out there. Those two are overlapping. Well, they shouldn't be. But if we come over to problems and we click this, it'll bring over the same drawer. Yeah, you see, look at that. Look at this. Look at that. He's a broken, huh? He's a broken. Hello, Denby. Sorry, I didn't see you there. I've been looking at chat. Trying to fix a z-index issue here. See that? Look at that. Look at that. Rubbish. Why is that broken? Why is that broken? I don't know. I've got to figure it out. Don't know. I don't know. Let's find out. Ah! What happened there? Documentation content. Here's the drawer. Here's the generic details of the drawer content container. And the shadow DOM. We've got the base. That's not it. This can't be right. There we go. Panel. Here's the header. Body. Here we are on the shadow. The shadow root. Looking at the shadow DOM. What is going on here? Hang on a minute. Let's try this. Well, that's easy. But we're just pushing the numbers up again. Do I care? Do I care? Do I care? Do I care? Do I really care? Because now this will be fixed. Fixed. SL draw part panel. That is defined in the drawer. So the solution. That's the solution. There's a longer term problem with indices. There is a longer term problem. I tried to avoid it. I knew that this would happen when I started this a few years ago. I was like, if I'm not careful, we're going to get into a situation where I've got random Z indices from 1 through 1,000. And whilst they're all in tens, there are a few that are slightly off. They're all in tens, but still, there's a lot of them. There's a lot of them. 31 matches in 18 files. Ugh. That's a job. There's a job for Claude. Not today. Not today. No, but it is a job for Claude. So I'm just enjoying a nice hot cup of tea. A hot cup of tea for me. Please, indeed. All right. We're going to go into WebStorm here. WebStorm. And go in to the draw. Where is it? Where is it? I pulled it out not too long ago. I pulled this out. What did I call it? What did I call it? Oh man. It's my drawer, but I can't. Where did I put it? Generic details drawer. I made it generic, but I don't know where it's gone. Let's find it. Details. Oh, man. Why couldn't I see that? It's right there. It's right there. Details drawer. Just sometimes I can't see what's in front of my face. I just can't see what's in front of me, like right in front of my face. Can't see it sometimes. Can't see it. Okay. Right. We are gonna sort out this CSS over here. Let's go zoom in. Let's go find it. Where are you? Where are you? Where are you? Where are you? That's interesting. I don't see it in here. Let's find out exactly where this is coming from. Oh, it is at the top. Why? God, I'm just details draw. Oh dear. Yeah. This is actually a problem. I need to fix this. So the problem is when as I was saying earlier, I actually pulled out this details drawer it was part of the problems view. The problems view is over here. So kind of close this off now. I'm looking at. Now we've done our debugging and diagnosis. Get rid of this. This details drawer evolved from originally being around documentation, and then I added in like how to fix, and then I added in the diagrams. So when I was adding the diagrams via the diagrammatron, this thing, when I was adding this, I was like, I just need to make this whole thing generic. I need to be able to have controls to collapse it down by a third, collapse it down by a half, expand it out full. It needs to be a thing because there's multiple things that are using it. So I've done that. I refactored it and it's working fine, almost. The thing that I have still got going on here is if we come into problems list. What is it? Problems. What is it? Problem list. Components. Problem list. It isn't problem list. Details drawer. Why I can't. I'm just struggling to see what on earth is going on here. Oh, there it is. It's like, must be that point of the day where I'm looking. It's right in front of me. It's the yellow. It's yellow. It's yellow. So I already changed this. The question is now, what do I need to change that value to? Sorry, I realised that you're still looking at that. Still looking over here. Couldn't see it, but this is what I was looking for, this details drawer. When I made it generic, which is, I've just been thinking through while I've been doing this. I made this details drawer generic. It was originally in this problem list. And for some reason, I'm still drawing on this CSS file. I think that's coming. Where is this coming from? So details drawer. I need to find. Let's do this. Let's do find usages. Task drawer. Yeah, and we're bringing it in here. All right, let's do this. Let's get Claude on this one. Actually, no, what? We just do it manually. It's just a waste of time otherwise. All right. Generic details drawer. Problem list. Details drawer. What else have we got in here? Example container. No, let me just move this straight in. All right. I'm going to do this. I'm going to get rid of this because there's only one place that it's used. Actually, no, it's not. It's used elsewhere, isn't it? Yeah, it is used elsewhere. Where was that? Where was that? Global tasks. Okay. I'm going to do two things. No, we're not. We're just going to move it for now. Don't need to change anything else. Love IDEs. I love IDEs because of this. Oh, thank you. Thank you. This should all be .js. Otherwise, Webpack will get upset. And the global task view has now been updated. Details draw. Great. Now we can just update in here. And what was it? It was giving it a Z index of, oh man, it was, oh God. Match there. We want this on top of everything. This should go over everything. But not the, I think this is 1,000 down here. I don't know. Ooh, all right, let's try this. Let's save that. And we'll come back over to Chrome. Let's see. We're looking in components, schema. We want booking payment, diagramify. Yeah. We are cooking. Woof. Okay. Looking good. It is looking good. Mission for the day achieved. We are 3 hours and 15 minutes in. I'm going to end it there. I think we've actually, before we do that, let's go and make those changes in Cowboy components and save our changes in. Actually, no, we'll do our platform first. Well, the changes that we've been making were not in here. They're not in here. They're in the doctor, aren't they? Okay, I'll review that code offline. Let's just we'll just commit that stuff in WebStorm that we were just working on with the details drawer, because it's nice and simple. But as you can see, there's a whole bunch of other things that I'm working on in here at the moment, which I'm not ready to commit. I'm not ready to commit in here yet, but I can fix these two things because they are permanently fixed. And what do we change over here? And the import. That's all that changed in there. Okay. Cool. Hang in here. Alright. Let's save that. So, sorry, I was just doing a double check. All of my commits start with that. The index. Commit. Let's commit those two. All right. Well, thank you for watching me today. We made some great progress. We reviewed some code, and we fixed some bugs and added some functionality, and actually rounded off pretty nicely. We rounded off the diagrammatron. That's now in a good place. The markdown generator, that's in a good place. Now we can get back to working on our GitHub integration, which is the next major thing, and then ready to push it out to everyone. Not yet, it's not quite ready, but we're making great progress. Those are two features that are going to be important in the future. particularly for downstream tools like OpenAPI changes. Thank you for watching today. Tomorrow we're going to, I'll probably do a majority of the code reviews offline today during downtime. But we will get on with building the next, well, the main feature, which is the integration with GitHub. It's about 80% done, but it's not quite there yet. There's still a lot of mechanics that are unwired and not complete, and use cases we haven't covered. So there's still a lot to be done over there, a lot to be done. But we made some nice progress on these two features. Thank you for sticking around. I don't know who's watching. If you are watching or you're watching on the stream later, I appreciate your time. Have a good rest of your day. I've got to go and do other things now. That time again. See you tomorrow.